Great, thanks, Laura. I'm happy to be here, and I really commend SaskPower for putting these sessions on and getting in front of people. And the power sector is straightforward for those of us that have worked in it for decades, and it's not that straightforward for the general public. So I'm happy that people are here to hear about some of the supply options, and I'm pleased to have been asked to talk to you about carbon capture and storage today. Let me just share my slides. Too many clicks. There we go. Great. Yeah, so I'll just jump into it here. I'll try to be as brief as I can and leave some time for questions at the end. A little bit about the International Carbon Capture and Storage Knowledge Center, besides having the longest company name perhaps in the world. We're a nonprofit. We're dedicated to advancing large-scale CCS projects. And we have a strong connection with SaskPower. SaskPower is actually one of our founding sponsors. Provide us with access to Boundary Dam Unit 3, the facility itself, operating data, things that we need to help other heavy emitters that are considering carbon capture and storage learn about the things that went really well in the Boundary Dam Unit 3 project, things that we would improve, and how we can ensure that they have the most successful project possible from the engineering sort of technical perspective. In addition, we work with people on the strategic side of projects, understanding regulatory requirements, funding opportunities, and public engagement, things like this conversation we're having with you folks today. So this is Boundary Dam Unit 3, just for a little bit of perspective. So this is the power plant here. There are 4 generating plants in the power plant area proper. And just to give you an idea of the scale of a 1 million ton per year carbon capture plant, what it looks like. So this is the carbon capture plant here, the compressor building beside it, and this is some of the heat rejection equipment. So these are major capital projects is really the message I wanted to get across. They take up a lot of space. There's a lot of equipment. It's really important to make sure you get these things right. And that's really the purpose of my organization, is to help people get these things right when they are considering executing these large scale carbon capture projects. The other thing that I'm not sure people realize is it's not really a competition. It's not one technology versus another technology versus another, and there's a clear winner. There's a need for everything. There's a space for everything. There's space for renewables, for storage, for nuclear. So it's important that we understand that we just implement all these technology solutions as effectively as we can. This is a very complicated sort of diagram giving an overview of the carbon capture process. I won't belabor it very much. I just want to point out a couple things. Oh, that's not me. I don't know who that red cursor is, but ignore the red cursor and I will find my arrow. I won't find my arrow. Okay, so there's an existing stack. There's an orange and white stack right in the middle of it. And really what we want to do is take the CO2 that's in the flue gas from whatever industry it is, be it cement, be it steel manufacturing, be it oil and gas facilities. They all produce some sort of flue gas from burning something, and that flue gas has CO2 in it. We've got a system that we can use chemically, remove that CO2 from the flue gas, absorb it, compress it, capture it and compress it, and then send it away for permanent sequestration. What I just wanted to point out, and I would like to be controlling that cursor, is quite fun. There are a couple energy requirements required associated with the carbon capture process. So one is the cooling tower, that blue area there. There's some energy required to cool some of the processes. There's the compressor, which is the arrow-shaped thing just to the right side of the big blue vessel in the middle, and that compresses the CO2 to a supercritical state of 2,500 psi. It's a large energy draw. And just the amine process itself that's typically used today requires a lot of energy, and it removes steam from the power plant process in this case. So I'll talk a little bit about those energy requirements, and then on the right-hand side of the diagram, there's some illustrations of what we do with the CO2. So the CO2 from Boundary Dam Unit 3 specifically goes to 2 different places, and it proves 2 different ways of safe permanent storage. One is the use of CO2 in enhanced oil recovery in the Weyburn-Midale oil field. The other is safe storage in a saline aquifer, which is in this case about 3.4 kilometers below the ground. So there's been a lot of research of the Aquastor well, which is used at Boundary Dam Unit 3 to prove what happens to the CO2 when it goes below the ground and prove that it's staying where it belongs. Okay, there's a lot of information on this slide, a lot of lot of data, a lot of numbers, and I'll go through it as quickly as I can. And I just want to point out a few things to you. I don't expect to try to get through all of this. But I'll draw your attention to these black diamonds. So the black diamonds illustrate the emissions intensity of the various types of generation. And they're oriented on this chart in this sequence. So coal, regular coal-fired power generation, which SaskPower still has a significant amount of. Coal converted to gas, which SaskPower doesn't have today, but is thinking about, and our friends in Alberta have done to quite a large extent. And natural gas combined cycle, which is something SaskPower has been building for the last number of years. Just a comparison between these three different types of fossil fuel generation, what their emissions look like in an unabated form and then in an abated form with carbon capture. So if you look at these two coal cases here, we've got a 300 megawatt case and a 150 megawatt case, which is the Boundary Dam Unit 3 unit. These are the actual numbers. The unabated emissions intensity ranges from about 1,000 to 1,200 tons per gigawatt hour of electricity. So pretty high. Coal has the highest emissions intensity of any power generation source that's out there in its unabated form. If you take a coal-fired boiler and you convert its fuel source to natural gas, you can cut that unabated emissions intensity almost by half. So it comes down to about 550 or 600. If you take the next step, which is what SaskPower has been building in the last couple of decades, is combined cycle natural gas plants. It's again a more efficient way of using the energy in natural gas to convert it to electricity. And the amount of CO2 it generates is even lower, down to 360, 380, somewhere in that range. So when you look at these two bars, the left-hand bar is the unabated view, and then the right-hand bar is the abated view. And I'll jump over here to Boundary Dam Unit 3's case. If you look at what the Boundary Dam Unit 3 can produce, it can produce a gross output of 161 megawatts of electricity. The net energy that can go to the grid is about 150 megawatts. So about 11 megawatts is used just to run the power plant itself, run all the equipment that's required to make the machine work. If you look at what happens when you turn on the carbon capture plant at Boundary Dam, the amount of electricity that's available to the grid comes down to about 111 megawatts. It comes down by about 26% from what it is without carbon capture to what it is with carbon capture. So that's the thermal energy requirement typically, or just the overall energy requirement for capturing the CO2 and compressing the CO2. So the blue bar here, this 14 megawatt bar in the case of Boundary Dam Unit 3, is the amount of steam that's required to regenerate the amine in the chemical process. The other bar is the energy that's required to compress the CO2, again, to that 2,500 PSI, and run all the other auxiliaries, the cooling equipment, the pumps, the heat exchangers that are required for the capture plant to run. So if you move from left to right to this on this chart, that energy requirement to run a carbon capture plant actually reduces. So if you take an existing coal-fired power boiler and you convert it over to natural gas, the amount of CO2 you produce is less. And that's the main driver behind this efficiency improvement. You no longer need to compress as much CO2 because you're not capturing as much CO2. You don't need as much amine recirculating. Your equipment can change a little bit in terms of the capture plant. So both this blue bar, which is the energy requirement to regenerate the amine, and this yellow bar, which is the cost of compression primarily and the station service for the capture plant, they both come down largely because you've got less CO2 to deal with, essentially. One of the other big advantages to going from this coal region over to this coal converted to gas region is you don't have fly ash and particulate and some of the other nasty things that are in the flue gas. It's a much cleaner flue gas in terms of the carbon capture system. It gets a little bit easier to do from a technical perspective. And then if I move over to the right-hand bars here, the natural gas combined cycle, better yet in terms of that percent reduction of electricity output due to the load required to run the carbon capture plant. Again, largely because there's less CO2. That's the real difference between the coal converted to gas case and the natural gas combined cycle case, is there's less CO2 in the flue gas. The compressor doesn't have to be as large, essentially. So a lot of numbers there, but just wanted to give you the overview of there's this energy requirement to do carbon capture, and it gets better as you move from unabated regular coal combustion to coal converted to gas to a natural gas combined cycle. So this is just a comparison chart that we borrowed from our friends in the U.S. government, and they pulled together a whole bunch of information from various studies and actual projects that are out in industry. And it was just interesting to have a look and see where our numbers stacked up, and they stack up very close to what these numbers are saying. So I'll just talk about so this is some of the non-renewable resources. So again, the fossil type resources and nuclear energy is over in this category as well. Some of the storage techniques, and then the renewable techniques. So wind, solar, hydro are over in this space, as well as biomass or biopower generation. So I'll focus on natural gas here. If you remember, when we do natural gas with combined cycle, we're down in this 360, 380, below 400, down in this region. If we do natural gas on a converted coal-fired power boiler, we're in somewhere here in the blue region, 500, 550. So the numbers line up pretty close with these unabated numbers that are presented here. And if we add capture, then we're down in the 20, 30, 35 sort of range. So right down here in the very bottom of the chart. So it does line up. So getting down to that 20, 30, 40 sort of range, it really lines up quite closely across the board. It kind of equalizes the emissions intensity of these generation options by capturing the CO2. On the coal side of things, so again, our numbers are pretty close. We show about 1,000 to 1,100 unabated emissions intensity. And the abated emissions intensity for Boundary Dam Unit 3 was down about 139, 140. So right down in the bottom, kind of where these orange bars are. So that's really what I wanted to show here is adding carbon capture to these fossil energy generation sources really levels the playing field in terms of that emissions intensity, and it gives SaskPower and other utilities another arrow in their quiver, if you will, to kind of hit those net zero targets, and allows all these options to be compared, whether they're base load power, they're peaking power, or they're kind of uncontrolled power that requires some grid stabilization, as you will have likely heard in some of the other conversations. The last thing I'll talk about is just what's happened in Canada to date. So Canada really is a pioneer and a world leader in terms of carbon capture and storage. Couple things we have, well, probably the main thing we have going for us is in Western Canada specifically, our geology is very conducive to long-term permanent safe storage of CO2. And we've proven that here in Saskatchewan for over 20 years now. But I'll just walk through these various projects. The upper left is the Shell Quest project, and that's a refinery in Alberta that's producing CO2. It's been running almost as long as Boundary Dam Unit 3. It captures a little bit more per year in terms of 1.2 million tons per year, and they've stored over 7 million tons per day. The Alberta Carbon Trunk Line is a CO2 transport pipeline that the government of Alberta built or funded in partnership with industry. And it's really there as sort of an infrastructure piece that allows emitters that are looking for a place to send and safely store their CO2 an opportunity to do that as cost effectively as they can, because the infrastructure is already there. So it's really good forethought, I think, on the part of Alberta to build that. So it's currently running at about 10% capacity, and there's a lot of action in Alberta looking at different carbon capture projects to fill up that 90% that remains. The next two projects are the Sturgeon Refinery, which is providing the Alberta Carbon Trunk Line with 1.3 million tons per year. The Nutrien Redwater Refinery that's providing 0.3 million tons per year, 300,000 tons per year to that Alberta Carbon Trunk Line again, to a single customer there, Enhance Energy. So the last two, or we'll talk about our Saskatchewan cases. So we've already mentioned Boundary Dam Unit 3, been in service since 2014, 8.5 years or so of operation. It's captured over 5.3 million tons per date now is the last photograph I saw from a site tour we did down there. Highly successful site, project that we're really sharing with the world in terms of helping people effectively build their projects. And then Weyburn. So the Weyburn EOR project, which is now operated by Whitecap, they've stored over 40 million tons of CO2 to date there. They've been accepting CO2 since the early 2000s for permanent storage from the Dakota Gasification Plant in the United States. And again, since 2014, they've doubled the amount of CO2 they take, up from 1 to 2 million tons per year by accepting CO2 from Boundary Dam Unit 3. So a lot of experience in Canada. I think there are approximately 30 active carbon capture projects in the world today, and 5 of them are in Canada. So we've really got a head start. We really are world leaders, and we do get a lot of questions from companies around the world asking about the Canadian experience and specifically the Saskatchewan experience. So I'll leave it there. I'll happily take any questions. That's a lot of information in a short period of time. And you can if you want a deeper conversation, I'm always happy to do that. You can contact us at the email address there.
Hey, thank you for this, Conway. Just for our audience members, if you toggle over to on the right-hand side of your screen to the session and look down, there's a Q&A function. And so feel free to type your questions in there and I'll pivot them over to Conway as we go. As we get started though, Conway, as people are thinking about their questions, I'm just curious, in this work that you've done over time, like and you're a technical person through and through. So did anything surprise you in what you've learned?
I was quite surprised at the reduction in terms of the energy penalty. And I have to stop using that word, but the energy requirement for carbon capture on a % basis when you apply it to natural gas combined cycle, being about half of what it is on coal-fired generation. I was quite surprised by that. I didn't expect it to be that much better. So I think it does make that a more attractive option for people than maybe people realize. That in addition to the relatively cleaner flue gas, where you don't have some of the challenges that have plagued Boundary Dam a little bit over its life.
You mentioned Alberta is kind of maybe not leading the charges the right way, but they've got more active projects underway that they're looking at. Yeah. Can you tell me from what you've noticed, what are they getting right in this, or maybe alternatively, what are they maybe communicating to you that they would do differently?
So Alberta is a little bit behind in terms of the number of sort of active projects.
Okay.
And it's hard to say what they've done right because everybody is still in these preliminary engineering phases of these projects. So some people have moved into their front end engineering design phase, but nobody in Alberta yet has done a final investment decision. So what we find really interesting is when we get in front of some of these companies that are considering or studying carbon capture projects, they don't know what they don't know. And then that phrase comes up a lot when we sit down with their process engineers that, maybe they're familiar with amine processes in different fashions, but they don't think about some of the details we've learned from Boundary Dam Unit 3. Mm-hmm. So it's quite interesting how much we have to share from the BD3 experience and how valuable it is to these people that, they just don't know some of these significant things they need to think about to build an effective project.
We have a question here. If SaskPower were to add capture to the new power plants, maybe at Swift Current or the one at Moose Jaw, I know we have a new one on the books with, I shouldn't say on the books, I'm sorry. We have one that's under the Impact Assessment Agency's review right now near Lanigan, where we've talked about this, adding it. What have you seen in terms of capital cost estimates? Or ranges, perhaps, whatever.
Yeah, I can give a bit of a range, and it's not cheap, as you can imagine. A 350 megawatt power plant requires a substantial capture plant, even though it produces less CO2 on a per unit basis. So it's anywhere from, it's probably in and around $1 billion. Pretty similar to what the BD3 actual capital cost was of about $900 million. Mm-hmm. That's what we're seeing for capture on a natural gas plant is about $1 billion, give or take. Now any capital cost estimate really has to be taken with a grain of salt today, given the current state of supply chain, the labor market, the inflation, price escalation that we've seen. But that's what we're seeing for a number, Brian, is around that $1 billion mark. So it's pretty similar in terms of magnitude to the actual cost of building the plant itself. Okay. So it's not small.
Pivoting over, we've had another audience question. CCS projects have sometimes been criticized for not accounting for the whole life cycle. So Mark Jacobs on Stanford, for example. So, it was kind of observed that it looks like you've shown that CCS does have significant carbon emission reductions. Are there any other hidden carbon emissions that weren't shown in your presentation?
Yeah, so I wasn't hiding anything, but there are certainly life cycle considerations in terms of the raw materials required to build the facility, transport of chemical to and from the site. There are some other things that we factored in. They would have been represented in that NREL slide that I showed at the very end. That was a life cycle analysis. The numbers that we use when we're working with clients, we don't get into the full life cycle today because it's such a small sliver of the overall projection when you're going from this unabated emissions of 1,000 to 500 down to 400 and then down to double digits sort of thing. So we don't get into that level of detail, but I think that NREL study did include the life cycle costs.
And sorry, just for those who are new to this space, what does NREL stand for?
Oh yeah, it's the National Research Energy Laboratory, and it's an arm of the United States government. So it's a highly recognized source of information.
You mentioned that there are 30 active projects around the world, 5 of which are in Canada. Which countries are you watching more keenly or with more keen interest?
That's a good question. So a lot of the activity up until maybe 6 months ago was happening in Europe. Norway was very much a leader. The UK is doing a lot of work, and it's quite interesting what's happening over there because they're not blessed with the same sort of onshore storage that we have. They don't have the same geology, and it's much more costly for them if they're actually looking at storing their CO2 offshore. What we've seen in the last 6 months with the changes that were made in the United States to their 45Q bill, which provides a production tax credit for CO2, they increased the dollar values. So now for any CCS project in the United States, they get $85 for every ton of CO2 that they capture and permanently sequester. And they get $60 for every ton that they permanently capture and use for enhanced oil recovery. So all of the analyses we've seen show that that's a much more lucrative and much more certain kind of regime, or sort of it provides a lot of certainty to developers. So we're hearing from a lot of industry that there's a push to develop CCS projects in the United States as opposed to Canada or other regions of the world. So there's a lot of activity in the United States, a lot of FEED studies that are underway today across all sectors, not just the power generation sector.
That's interesting. So, another question here. So, and maybe this feeds into the business case in and of itself. If you're looking at incentives, like what kind of market is there for CO2, right? And is it difficult to find companies who want it?
Yeah, there's kind of two pieces to that question. So there's a market for CO2 in the case of what SaskPower has done for enhanced oil recovery. I know the Whitecap. Emergency alert. I know the Whitecap operated facility in Weyburn-Midale would be happy to take more CO2 if they could get it. The challenge is the regulatory regime in Canada. There's an investment tax credit available for companies that execute carbon capture and storage projects that gives back about 50% of the capital investment, and it excludes enhanced oil recovery. So in terms of a market, it's actually not financially attractive right now for carbon capture project developers to sell their CO2 to a market for something like enhanced oil recovery. There are a number of utilization techniques that are being researched, and there's some progress being made there, but the scale, the number of millions of tons that are required to meet our net zero obligations, permanent sequestration is going to be required for the next decade to actually store the CO2. So in terms of a market, that there really isn't a market for the CO2. It's just layering it into the overall business case of avoiding carbon taxation, utilizing the investment tax credit, utilizing other government funding sources from things like the Strategic Investment Fund to help make these projects make economic sense. One thing I'll just add in is the projections from the government of Canada are that by 2030, to keep us on our path towards net zero by 2050, they're projecting a need for 15 million tons of additional CCS projects to be in place by 2030. So essentially 15 more boundary dams between now and 2030. And when we look at a carbon capture project, we say there's about a minimum 6-year life cycle from start to finish to actually execute one of these projects. So there isn't a lot of time to get these projects done in Canada.
That's interesting. I'm going to put a non-technical question to you on that vein of timelines. In the space that I operate in, I am seeing definitely an increased expectation for public engagement, formal consultation where the duty is triggered. And certainly we're seeing that reinforced with regulatory processes. And this doesn't necessarily line up to hitting those same targets, right? Move quickly, but do this, and it's all important work. And so I'm just curious, like, what's your perspective on that? Or we've got lots of projects you cited who haven't actually put shovels in the ground yet. What else are you seeing there? What's your thoughts or take on this?
I think that's a fantastic question, Laura, and the short answer is we're late. We should be doing public engagement in the carbon capture space, even though we know we've done it in Saskatchewan, we've done it in Canada safely for a number of years now. As you would know better than I do, the requirement for public engagement and allowing people to understand what a development is going to look like, what it's going to do, is very important. So we're starting to see people protesting against these projects, the long-term storage, the construction of pipelines. It's something that the carbon capture sector does need to get moving on very quickly. And it's something we're talking to all of our clients about today. And we probably weren't talking to them about it as much even a year ago. But we're really seeing the need for more proactive public engagement.
What kind of resources are available through the International Knowledge Center? If we were to go there, what would we find? For instance, would I find information on the aquifer storage studies that have been done or the conclusions?
You'd find a lot of studies and white papers about the application of CCS across various sectors. We've written white papers about sources of CO2 and combining those sources into common hubs for storing CO2. We recently wrote a piece around the investment tax credit in Canada, helping give industry a little bit of perspective of what that investment tax credit looks like, what it means for them. So we do a lot of work to help the CCS sector understand sort of the regulatory carrots and sticks, what's available there to help their project, what's available there, what's in place to force them to do their projects in some ways. But we try to make sense of that landscape. So you'd find a lot of publications on our website. And we have a quarterly newsletter that we issue where we share a lot of that information as well.
Hey, well, thank you very much for your time and for coming out today, Conway. I see it's 2:00 on the nose. For those of you who stuck with us, and it looks like everyone did, thank you so much for participating today in our Power Talks event. Watch your inbox for a feedback survey. We'd love to hear about how your experience was today, as well as what you're interested in. I think this is something that can continue on. We can have guests like Conway come back or keep going. You can also go to the replay section of this website. Within 48 hours or so, we'll post the recordings. So anything that you missed, you can catch up on, and we'll look to post it on saskpower.com/engage. So thank you again to all, and have a great afternoon.
Thanks, everybody.